One of the great technological advancements of our age capable of optimizing our home lives are smart plugs. These devices operate the same as normal plugs except that they are connected to the internet, which gives us the ability to monitor and control if our appliances are consuming power from any device via an internet connection. A recent trend in homes going off the main power grid and making use of solar panels and DC grids have inspired the creation of DC appliances that require DC power instead of AC power to operate. Removing the conversion between the DC power produced by solar panels to the AC power expected by everyday appliances has proven to greatly reduce energy loss caused by inefficient inverters. Thus, a gap in the market has formed for DC plugs and especially for DC smart plugs. Furthermore, the DC home is built on energy efficiency as its prevailing motivation. For this reason, developing DC plugs that measure and display energy usage almost seems invaluable. Many homeowners will however state that the smart plugs are simply too complex or expensive to install in their homes. We however address this common technological problem by using modern-day cloud technology. To solve our problem, we split the project into two components, each consisting of several functional units. Firstly, the DC plug was designed using an ESP32 microchip to give us advanced control and monitoring capabilities over the electronics used in the plug. The ESP32 microchip also provides communication capabilities to our plug at a low cash and power price. Power measuring was achieved by making use of our microchip's analog to digital converter that can accurately measure the power usage to 3 Watt. A combination of hardware and software filtering was used to produce this consistent measurement, while still keeping the production cost of the plug down. The most important part of the DC plug is the method of switching DC power, as it is far more troublesome than switching AC power, since arcing is a very real and dangerous aspect of DC switches. For this reason, a low-cost hybrid DC switch was developed that can safely step up or down DC power, while keeping the plug itself small and low cost. Lastly, communication protocols for the user and server had to be developed. The user can easily communicate with the plug using the power button or a local control portal hosted over Wi-Fi. The plug also communicates to our server in the cloud, making use of the lightweight MQTT protocol. The cloud-hosted server contains all of the components needed to communicate with the plug, store data, and host an accessible and easy-to-use web application. This scalable cloud-based approach enables us to add many plugs to the system without our users needing additional hardware, other than their smart DC plugs. Combining these functional units gives us a safe-to-use, low-profile DC smart plug that can easily be set up by anyone. And by using the dedicated web application, the user can easily control or monitor their appliances from any mobile device or computer. The web application also consists of some additional features, such as setting up timers for your plugs to automatically turn on or off at specific times, viewing past usage data, or exporting all of your data for self-analysis or record-keeping purposes. We hope that this project will continue to drive for the more connected and energy efficient world we deserve.